Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at independent events. So in a previous video, we learned that two events A and B are independent if and only if probability of A given B equals probability of A. And that makes sense because what this statement in red says is that B happening didn't change the probability of A. So it turns out we can manipulate this formula and we find an equivalent statement here. These two are equivalent. So if two events are independent, then probability of A and B equals probability A times probability of B. This is a very, very useful tool in probability. So I'll illustrate that with an example. So let's say I toss a coin 5 times. Let's calculate the probability of tossing at least one head. So it turns out each time you toss a coin, the outcome is independent. It doesn't matter if you got a head the last time you tossed a coin, it's still 50-50 the next time you toss a coin. So because these events are independent, I can multiply for AND calculations. What do I mean by that? So the probability, for example, that I get 5 tails in a row, basically what I'm saying is probability I get a tail on the first go and a tail on the second go and a tail on the third go, it would just be a half times a half times a half times a half times a half. So I can do that much quicker by just writing half to the power of 5. I can only use this logic because the events are independent. If the outcome on the second coin depended on the outcome of the first coin, we couldn't use this logic. So a half to the power of 5 is 1 over 32. That's the probability of getting 5 tails in a row. So how does that help us calculate the probability of getting at least one head? Well, sometimes in probability, it's easier to calculate the probability that something doesn't happen. And notice that not getting at least one head is the same as getting all tails. So this was really easy to calculate. These two events, so getting all tails and getting at least one head, they are called complementary. And if the probability of an event is X, the probability it doesn't happen, so the probability of its complement is 1 minus X. So the probability I get at least one head is 1 minus the probability I don't get at least one head. Our final answer here is 31 over 32. All right, let's try this one. I roll a die twice, calculate the probability I roll exactly 1 to 6. So the problem with this one that a lot of people forget is there are actually 2 ways that this event can occur. So I could get a 6 on the first roll, but not on the second roll. And I could also get a 6 on the second roll, but not the first. All right, so what's the probability of getting a 6, then not a 6? Well, the probability you get a 6 on the first roll is 1 over 6. The probability you don't on the second roll is 5 over 6. And these two events are independent. What you roll on the second roll of the die really doesn't depend at all. It isn't affected in the slightest by what you got on the first roll. So that's why we can times them together. Probability you get a 6 and then not a 6 is 1 over 6 times 5 over 6. And it's a similar story over here. The probability that you don't get a 6 and then do get a 6 is 5 over 6 times 1 over 6. Now in probability, we need to be really careful and really understand, are we completing an AND or an OR question? So this was an AND question, this was an AND question, but when we want the probability I roll exactly 1/6, we're saying what's the probability that this or this happens. When it's an OR problem, you actually add them. So my final answer here is going to be 5 on 36 plus 5 on 36 is 5 on 18. So as a general rule in probability, when it's OR, you plus, and when it's AND, you times. That is a bit of a crass rule because remember, to use this rule, the events have to be independent. Turns out for this, they have to be mutually exclusive, but this is just a rule to help you understand. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.